Hello everyone and welcome to my channel to a new tutorial from the Electronics from Zero to Infinity series. Today we will talk a bit about equipment, tools and accessories that we need to work in a small electronics lab, no matter how small it is. Before we start, I need to make a few explanations. First of all, this tutorial has been initially created in Romanian, so throughout this tutorial you will see various images with text written in Romanian, images about products that we can find here locally. Don't worry about those, I will explain them as we go, and I will also give prices in dollars or euros. I will calculate them automatically. Of course, there are many other videos on YouTube on this topic, especially made by various other English speakers. However, sometimes we can discover that what they recommend are a bit too expensive than it is necessary. This is why I decided to make a video for this topic myself. It is, after all, my pretty personal opinion, but I will also have objective reasons that I will explain. The idea overall is that we can have a small electronics lab with lower costs. We can do stuff in this domain as amateurs, even if we don't want to pay something like $2,000 or over $2,000 or euros on the necessary things. Because I live in a small two-room apartment, I can't afford, like other hobbyists, to have a garage or a larger space that I can make as an electronics lab. Fortunately, this thing does not pose a big problem. I could transform just a small part of my bedroom in a workplace, and this proves to be sufficient, at least for the beginning, as an amateur. I could build custom wardrobe inside of which I could lay this empty space, and therefore I don't need another separate space to have from my bedroom as a workplace. Of course, this is just an idea and it worked for me. You could do something else, like a regular desk, maybe some place in a corner of your chamber. It really matters less. What matters is that you will need about 1 square meter of space for you to work and also lay down various devices that you will need. Devices that you will have to make often use of, and therefore you will wish to leave them on the bench at all times. It is possible that you could work with less than a square meter. However, from my experience so far, I've seen that this surface can be filled pretty easily with all sorts of circuits, components, accessories, and various devices that we need, like measurement devices. Next, the things that we need can be split up in multiple categories, such as basic tools, electronic devices and appliances, accessories, components, modules, and sub-assemblies. We will talk about the last category in a separate tutorial because it has many other subcategories. Now we will talk only about the first 4 from this list. Number 1. The basic tools. Now, I call these basic tools because I don't consider that I should be talking about them. I consider they are so basic that any person should have them in their homes, no matter what. Because they're not tools specific to electronics or tools specific to people who are in the do-it-yourself domain. They are tools that should not be missing from anyone's house because they can be used in so many situations that you just need to have them. But for the sake of having a consistent presentation, I will include them here. So these are a few pliers, at least a normal one and a sharp nose one, a few cutting pliers, a few screwdrivers with a cross head, a few screwdrivers with straight head, cutters and scissors, a pricker and or other sharp tools to manually drill holes, small holes. A set of clockwork screwdrivers. A screwdriver with interchangeable head set. A few small files, a ruler and a tape measure, a caliper and a micrometer, 1 or 2 brushes to remove the dust. This can be taken from a shaving device, haircut device, a set of hair dye, or anywhere else, and a set of tweezers. Out of all these tools, I would recommend at least the screwdrivers and the pliers to be of decent quality. At least decent quality, because they are the most used tools in my experience. Optionally, it helps a lot if you would also have an electric screwdriver and a small vise, a hand vise or a vise that you can apply to a table, to fix to a table. Based on how many other things you would wish to build, it is very likely that you will also need a hand milling machine like a Dremel, but it doesn't necessarily need to be a high quality one, it can be also a cheap Chinese one. An electric drill with possibility to plug it to the wall. Those that run on batteries tend to have lower power. And of course a set of drill bits for the various materials in which you would need to drill holes. Wood, metal, brick, wall, etc. This can also be a cheap electric drill. An angle grinder and a few cutting discs. A jigsaw and a few cutting blades for cutting wood, metal, etc. A glue gun with silicone and 1 and 2 sets of silicone cylinders. Number 2, electronic tools. When it comes to electronic tools, we have to mention those tools that belong strictly to the electronics field and which normally do not get used in other situations. So here we have a soldering iron, a soldering gun, or a soldering station. Here we would need to have a little discussion. First, I recommend buying such tools that have at least decent quality. I do not recommend that you buy the cheapest ones. Second, you want to make sure that the power of these tools is as high as possible. A weak soldering iron will not be able to melt the solder from the big pieces of metal because all the heat will be absorbed by this metal and not enough heat will remain in the area where the solder is. There's also a subjective factor, the personal pleasure, that might make you tend towards either a soldering iron or a soldering gun. Personally, I am currently almost exclusively using a soldering gun, at least for soldering wires and components, both within themselves and on the PCBs. I like the fact that a soldering gun heats up very fast in just a matter of seconds, and I can work with him very easily. On the other hand, I also bought a soldering station, a double soldering station with soldering iron and a hot air blower. Although the hot air blower is meant to work with SMD components, it is very useful in other cases as well. And this is what I would also recommend to you. Buy a double soldering station and a soldering gun. Soldering gun for normal solderings, the station for hot air working, and this way you will also have a soldering iron as a spare in case the soldering gun gets broken. Tool number 2, a desolder iron, desolder pump or desolder station. Honestly, so far I've managed to desolder the great majority of components that I desired to be desoldered from the PCBs just with a soldering iron or a gun. However, I do know that there are cases like the integrated circuits in which you cannot desolder certain components because there are way too many leads and too much solder that keeps them glued on the PCB. In these situations, a desoldering tool is very useful. Fortunately, there are cheap ones, so this should not be a big problem. Tool number 3, a magnifying glass support with pliers. Very useful when we want to stabilize a PCB in order to solder various components on it. You can buy one from various shops, which I also did, but I also created one myself with 3 pliers, a small piece of wood, and 3 metallic small strips. Bonus, tool number 4, an electronic microscope. It's not a must-have, but sometimes it proves to be very, very useful. And on top of this, it only costs about $50 or so. The huge advantage is that you can connect it to an Android device with Android version at least 7 through an USB on-the-go cable in order to directly display the image. In other words, you don't really need a computer nearby to connect the microscope to it. It's very useful in order to read very small inscriptions from certain components, in order to inspect PCBs, in order to search for possible mechanical flaws, and many other situations. 3. Electronic devices and appliances. Here we can have long discussions about what we would need and what we would not need, but I will try to keep everything simple. I will just assume that you are like me, an amateur that slowly tries to create circuits and devices, gradually increasing complexity, but that does not wish to throw himself directly to extremely complex and difficult projects such as radio frequency circuits. In such case, we would need the following. 1. Multimeters. Regardless of what we are doing, we need a few measurement devices. For this particular purpose, I recommend buying 3 digital multimeters and 2 analogic ones. Most of the times we will see that we need to measure multiple things at the same time. That's exactly why I'm recommending you to have more than one. The idea is as follows. I recommend that you have a digital multimeter of decent quality or high quality if you can afford one. It doesn't have to be $1,000 or €1,000 one, but it needs to be decent. I recommend that it can measure temperatures as well with a thermocouple because it's very, very useful. We will need to measure temperature at which certain components can rise, and they are typically mounted on heat sinks. So for this, multimeter that can measure temperatures is very, very useful. Then a second multimeter can be something relatively cheap, like a $10 one. The third multimeter we would want to be a clamp meter so that we can measure AC currents through induction as well. Besides these 3 digital ones, I would suggest you also have 2 cheap analogic multimeters for the cases when we need to observe rapid changes in values. Now, if I am to speak about what my multimeters are, as a decent quality multimeter, I have bought a few good years ago, a Veleman DVM 8264. Sadly, this model is not produced anymore, and I haven't seen anything similar from this brand. Right now, if I were to have no such thing, and if I were to have to buy a decent multimeter, judging strictly by prices and by the various specifications that I can get from the products on the market today, I would probably choose a Pictech P3690, which is somewhere less than $100 or €100. I don't mean to make some sort of commercial to any brand or model in particular. I'm just making an opinion on what I would do if I would have to do such a thing, to buy a decent multimeter. According to the specs, it's a pretty nice multimeter. It measures quite a lot of things, and the price is quite decent. So basically, this is what I would buy, and therefore this is what I would be able to recommend. Bear in mind though that I have no experience with this multimeter, so I cannot guarantee that it's a good quality one. Again, just my subjective opinion. As a cheap multimeter, I have a Plusivo one. It's roughly €10, $15, something like that. and it's a decent multimeter for its price. You can work with it, especially once you calibrate it. As a clamp meter, I have Unity UT201. Although I bought this model a few good years ago, it's still available on the market, so you can still buy it today as well. It's around 20 euros or $25. And personally, I've quite been impressed with it. It's never been calibrated, and yet after I bought a calibration module that gave me 2 fixed voltages, he was able to measure these voltages precisely, even though it's never been calibrated, even though I bought it some 5 or 6 years ago or something like that. So I would say that at least this model from this brand, it's a pretty good quality for its price. As analog multimeters, I have a couple of YX1000A ones. I'm not sure if you're gonna be able to get these in your country. I'm not sure even what brand these are, but in my country I can get them for something like 4 euros, $5, something like that. So I would recommend that you get 2 of them. You won't get a lot of precision with them, but they are not meant to give you accurate reading. They are pretty good when it comes to measuring values that change rapidly. And you want to have an analog multimeter so that you can just watch the needle go up and down. The second type of electronic devices that we need is an oscilloscope. Now, once again, there would be a lot of talk on this topic. The oscilloscope is sadly an indispensable device because it's the device through which we can see the electric current from our circuits. Now, there are really great performance oscilloscopes that we can buy only if we sell the house in which we live. Fortunately, we don't need to do that, and we can't even think about them. But we can work with far less than that. I would personally go in 3 ways based on possibilities that we have. On one hand, there are extremely cheap oscilloscopes considered to be toys, basically, but that do their job decently for the beginning. They cost about $40 or so, 35 euros, $40. And they can come either in a form of a kit that we need to assemble, either in a form of a PCB with already soldered components on it. In both of these cases, we would need to fabricate a case for them. I have 3D printed one, but of course there are other possibilities as well. These oscilloscopes go up to 200 kHz, and this frequency should be high enough for beginning for many amateur electronists. The second option that we would have would cost a bit more, and it would depend a lot on the luck that we have and basically where you live, what your possibilities are. I'm talking about the option of buying second-hand oscilloscopes from someone like a radio amateur. Personally, I managed to buy 2 of these old cathode ray tube oscilloscopes for the price of about 70 euros, $70 a piece. They were both sold by 2 radio amateurs. They are definitely better than the extremely cheap oscilloscopes that I've talked about earlier. They work at about up to 5 or 10 megahertz, but whether or not you will be able to get one is, well, like I said, a matter of luck. The last option would be to buy a modern oscilloscope, digital one. And a decent one for what we would need in the beginning, we could find between $300 and $600 or euros, depending on the situation. The third type of device and apparatus that we would need would be a power supply or several power supplies. No matter what we would like to do, electronics is about electric current passing through a circuit. In other words, we would need to first have this electric current, and then we can discuss about where, how much, and how this electric current passes. So it's pretty clear that we need at least a power supply with which we can fuel our circuits and devices that we are building, at least when we are designing them and testing them. For the beginning, we would need a double power supply or two simple power supplies of DC current, constant voltage, adjustable in an as wide range as possible, capable of giving us as high current as possible. I would say we would need at least 1 amp, preferably 3 to 5. If it's possible, maybe even 10 amps for the cases when we would want to make experiments with high power circuits. That would be perfect. Here we could have a bit of a discussion. On one hand, we could buy such a power supply from the market. On the other hand, we could build it ourselves because it's not a so difficult project. Now, of course, it's not exactly for beginners. I would say you would need to be of medium-level electronists, so to speak. But the idea is that it is possible to build a power supply. It's not impossible. The advantage of buying a power supply from a company is the fact that we can have it very fast. There are companies that have power supplies on stock. Disadvantages are, however, several. First of all power supplies that you can buy, or most of the power supplies that you can buy in the market, are switch mode power supplies. This would not be that bad, but from what I understand, switch mode power supplies are to be avoided in radio frequency circuits because the electric noise that they introduce are quite high. So if it's possible, we would want to have linear power supplies because we never know when we need to power such a circuit that has problems with high frequency noise. The second disadvantage is the price. If we manage to build a power supply ourselves, we would have fabricated it at a considerably less price than what we would be able to buy from the market with the same specifications. For example, I managed to build myself a dual power supply of 20 volt, 10 amps each at a cost of approximately 60 euros or $70 per power supply. The cheapest power supply that has the same specifications cost at least double. Dimensions can also be a disadvantage. The power supplies that we can buy from the market can be most of the times bigger. Even if they are not bigger in all dimensions, we can discover that at least one of the dimension, for example, depth, width or height, can be a bit too big for the space that we have on our workbench. So when we are able to build our own power supply, we can take into account these maximum dimensions based on our situation. 4. Signal generators or function generators, also called arbitrary waveform generators. Now, I have to admit I have a problem with this as well. I'm currently working on a signal generator because the ones that I can get from market cost a bit too much, and the possibility of creating such a signal generator is not impossible. It's not that difficult. But for the moment I don't have, so I cannot talk too much about them. What I can say is that a signal generator is very important when we want to design circuits that work with AC, regardless of whether it's audio equipment or radio frequency equipment. When we want to test such a circuit, we need to be able to introduce a certain signal of a certain frequency and amplitude to its input in order to see what happens in the rest of the circuit. That's why we need a signal generator. Now, in order to give a few such signal generators from the marketplace, we could mention this function generator that goes between 0 and 3 MHz, GW Instec SFG 1013, which at least in my country sells for about 240 euros, $250 or so. This Pictec P4025 function generator that sells for about 500 euros, $600 or so. or this TTI TG1000 digital function generator that goes up to 10 MHz that sells for about 480 euros. Regardless of that, we will be talking more in the future about the devices that we may need in an electronics lab. It's impossible not to discover that a certain device, no matter how trivial it is, doesn't prove to be very useful in certain situation. I will make a separate video on this topic. For the moment, we will stop here. We need some multimeters, oscilloscopes, power supplies, and maybe a signal generator. And now let's go to our final point on the list: necessary accessories. So besides the tools and devices that I've presented earlier, we would also need a few consumables and accessories. In a somewhat random order, I mention solder and some rosin or flux for soldering components and wires, breadboards for prototyping, and I recommend you buy more than one because a breadboard can be filled pretty fast. A few cables for breadboards in the order of tens, preferably buy a set. A few cables with crocodile clamps on each end in order to connect various components, devices, circuits. Now, these kinds of cables can be found already made, so you can just buy them. However, I decided to just buy myself the clamps separately and the cable separately and make such cables myself for whatever length I desired. This would be all for beginning. Of course, as we go, as we advance in this field, we will surely discover that we will need all sorts of other tools, instruments, accessories, but it's good to take them all one at a time. Thanks a lot for watching this tutorial, and hope to see you soon next time for a new one. Bye!